question?
I haven't even started yet. How can you have a question? There are some general rules that will help you solve any type of equations you come across. And we're going to go through these general rules and then look at some examples. So, general rule number one, brackets are bad, distribute them out. So, distribute them out. Where you can, collect like terms. So, if you have x's on the same side of the equation, collect them together. Numbers on the same side, collect them together. And we'll see how this works in the second example. In general, fractions are bad. You want to combine them, and there's a couple of strategies for that, and then multiply them out, or cross-multiply, and we'll look at how that works. Remember, at all times, your aim is to end up with x on one side, all the numbers on the other. And finally, don't freak out if it looks hard. One step at a time, we'll get it through nicely. So, first equation here. Pull it up nice and large. General one is we don't like brackets, so we distribute them out. And what that looks like is the 4 comes out here, and that one goes out there. So as we pass out these, or distribute it out, we have 12 plus 8x. And the trap here is that is a negative 2. So the negative 2 gets distributed out. Negative 2x minus 2 equals 5. Alright? Then, if you have like terms on the same side, it works nicely if you collect them. So, that 8x and the negative 2x are like. Same with the 12 and the negative 2. Note how I'm keeping the signs in with the colours. They're like because they're either x's or numbers, meaning we can combine them. The 12 and take 2 gives us a positive 10. 8x take 2x is positive 6x. And note that I haven't done anything to the other side. All I've done is expanded out or distributed out and then collected the like terms together. And all of a sudden what we're looking at is something that looks much, much nicer. Good, and now we're reducing it to find x, so we peel away the layers around x, ditching that 10 off both sides, leaving us with 6x equals negative 5. Dividing out that 6, dividing out the 6, leaving us with x as neg 5 on 6.
So do you just leave it there, or are you supposed to actually divide?
No, leave it there. In the PAT, you may get some guidance. They may ask you to answer to the nearest whole number, at which case you'd answer negative 1. They may ask you to answer to the nearest tenth, at which case you'd swear a little bit at them, and then divide 6 into 5 and work out what that is as a decimal. Torrin.
Is this one of the questions on the algebra extension 1?
Possibly is, yes.
Because for some reason, I feel like I did it on the website and it said it was wrong. But
please excuse the interruption. Can the following students please come to the senior high office? Mauricio Garcia, Caden Hill, Kian Malone, Ibrahim Mirza, Austin Thirst, Taylor Belker, Andrew Wilfing, Barwan Hazel Ali. Again, the following students please come to the senior high office. Mauricio Garcia, Caden Hill, Kian Malone,
and
Ibrahim Mirza,
I think that's the right answer.
Austin Thirst,
It just might
Taylor Belker,
something might be wrong.
Andrew Wilfing.
Okay. So, next one here, same sort of strategy, but one step harder. Distribute brackets, collect like terms, ditch numbers one side, x's the other. So you guys can have a shot at it as well, and then keep looking up to make sure yours is working out the same as mine. If you're not sure what on earth is going on, just wait, make sure you get the notes down, because you will have to do stuff that's complicated eventually anyway. Ben?
So, you see how there's a plus in the bracket?
Yep.
Would that become a subtraction or stay positive?
No, that one stays as a plus, so it still stays as 2x plus 6, but you're right, the next one is a trap. The next one, because there's a minus 5 out there, it changes the sign on the inside. So the next step in the expansion will be minus 5 plus 5x equals 6.
That's disgusting.
It's a beautiful thing. It just flows out.
Sorry guys, the vaccinations today, they had to do some early. They are being done right now, so if your name wasn't called, you're off the hook till the new year. Which is annoying, and I apologize. I thought we were all being done.
Everyone's been stressing this morning.
What if? Not stress.
There's no what ifs, there's nothing today.
No, I mean like
Whose name's
on, like we're getting him in February, right?
The new year is all they said, he told me.
'Cause
But when I know, Adam, you will know, okay? Okay? Sorry guys.
For the 6 minus 2x, would that
Yeah. So Samara's looking ahead and has spotted the next trap here. A negative out the front of a bracket
Would go
really implies there's a -1 hiding there. That -1 then affects everything inside the brackets. So it becomes -2x -3. So be very careful of the signs. The negatives will change everything around. That negative there changed the sign of both things inside this bracket. That negative with the other ones inside that bracket. Alright, now next step, where we can, we collect like terms. So collecting like terms is when we have the same sort of terms on one side. That +6 and -5 are like. 2x and 5x are like. So the 2x and the 5x give us a 7x. 6 take 5 give us a +1 on that side. Alright, let me know if I'm going way too fast. On the other side of the equation, there's nothing to play with the x, there's nothing like with the x, but the numbers combine to make 3. 6 take 3 is 3 minus 2x. And now we're in familiar territory. This looks like what we're doing in level 6 and level 8. So where we had x's and numbers on both sides, it's looking nicer for us. Our aim is to get the x's on one side, numbers on the other. Anyone got any ideas of what to do next? Yes, Ben?
Do you subtract 1 from 3?
You could. You could subtract 1, subtract 1. And that would leave us with 7x equals 2 minus 2x.
Then add 2x.
Good, then add 2x. We want to chuck the x's on the left. So we're going to add 2x, giving us 9x equals 2. And then divide by 9. It's kind of fun to see something that complicated sort of narrow itself down into an answer. It's also incredibly frustrating because one tiny error, one sign missed, and you won't get it wrong. But we're practicing. I should point out that this is about as hard as I've seen in the PAT. The next ones we're going to do get a little harder. The purpose of going harder is, so have you ever heard the saying sort of train hard so then you win easy?
Yeah.
Yeah, so we're training hard, as in we're going to go a little harder than the PAT would generally have, so that when you go to the PAT, actually it's not too bad, if that kind of makes sense. Alright, next up. This one here. As a general rule, we don't like fractions particularly. We would like to combine them, then get rid of them. How do you combine that as a fraction? Good. Common denominator? Yeah. Same number on the bottom. What's a good number to aim for if we've got a 3 and a 4? 12, lovely. So we're going to say, well, that has to go over 12, and this one's going to go over 12 as well.
And then would it be x squared on top?
Close. What did you do the 4 to get it to... Sorry, what did you do the 3 to get it to 12?
So 4.
Times 4. So times 4, whatever we do at the bottom, we do to the top. Same with the bottom here, same with the top.
So it would be 4x and 3x.
Yes, well played. Okay, so no, we haven't done anything to the other side because we haven't changed anything here really. We're just rewriting the fractions to make it look nicer for us. What is 4x on 12 take 3x on 12? If we're going to simplify that down. Yes, 1x over 12. And now that looks much nicer. How do we ditch the... Yeah, go for it.
You multiply the 12 by 12 to cancel it, and you also multiply the 6 by 12.
Lovely.
How do we go from 3 to 6?
Thank you, Keaton. Because I was special. X equals 36. Oh, great, and that's recorded. Love this game. Love this game. Alright, next up. Now, I'd just like to show you here. Oh, I didn't mean to do that. I'm just going to erase this, but you don't have to write the next bit down to show it in a little more detail of what kind of happened. You guys will have seen cross-multiplying before. Really, what happened here is we multiplied the 12 up there and the 1 up here. When you have a fraction either side of an equal sign, only when it's either side of an equal sign, you can cross-multiply. 1 times x is x. 12 times 3 is 36. And that's what's happening when you have a fraction inside of an equal sign. You cross multiply them up and it gets rid of both fractions. So on that note, we come to here. Our step here is, in general, we dislike fractions. The way we get rid of them is that cross multiplying process here. So that 2 is going to come up here, that 3 up there. And this cross multiplying step jumps the 2 out the front here. 1 take 2x. Oh, come on. X equals 3x plus 4. So 2 up, 3 up. No, I put them in brackets because we want to multiply the entire top. And now it looks vaguely familiar, doesn't it? So plan from here.
So
Distribute.
Yeah, good. Distribute. So throw them in there, that in there. We have 2 take 4x equals 3x plus 12. What you do from here is largely your own choice, as long as you're aiming to put the x's on one side and numbers on the other. I'd probably add 4x. Add 4x. And that will give us 2 equals 7x plus 12. Good. Take 12 to get the numbers all on one side. Neg 10 equals 7x. Divide by 7, divide by 7. Neg 10 on 7 equals x. Or you could write x equals neg 10 on 7 if you like seeing x on the left.
Okay.
Now,
So for this one,
that one there, if you were putting it into go formative, you would answer as neg 10 slash 7. It would be legitimate to say this is negative 1 and 3/7, but go formative likes you putting it as an improper fraction. So that would be as far as you go. Ben?
To put this in go formative?
No, this one's just your note sheet, but they will line up with go formative, and I've set you up on go formative, if that's what you're going to ask.
For the fraction questions, like on the exams,
Mm.
are we, like, will it ask for us to reduce it into lowest terms?
Yeah, and that should be sort of a given, even if it doesn't ask. Try to go lowest terms. But good question. All right, next up. Torrin.
Would you cross multiply?
Yes. So once again, fraction facing a fraction, good strategy is to cross multiply. This goes up there, this goes up here, but this one's particularly nasty.
because
What?
2x
X
times
on the
12.
outside of 2x.
Squared. When you have an x times x, it's squared. 3 times 4 is 12.
So would you square root?
In a second, yes. So you have to unwrap the x, and we ditch the multiply 2 first.
So
I reverse my best. So we divide 2, divide 2,
so x squared equals 6,
6.
and then square root.
Good. So opposite of squared is square root. We're going to square root both sides. So if you want to write the working set, you sort of write it like that and like that. And therefore x is equal to square root of 6. Now, a couple of technicalities. Technically, it should be plus or minus 6. Both solutions work, but at grade 9, we're not going to ping you if you forget the plus or minus. Can we take a guess at approximately what root 6 is as a decimal? Yeah, Dale? Sorry, Torrin?
2.5-ish.
2.5? Yeah, 2.5-ish is pretty good. But like that, somewhere between 2 and 3, certainly. So it would be possible for the PAT to ask you to find this to one decimal place. Alright, last one. You guys are doing very well keeping up. Cross multiply only works when you've got a fraction facing a fraction, single fractions on either side. But it's certainly a goal. Our goal is to make it look like a fraction facing a fraction.
So would you do what's called common denominator?
Yeah, common denominator. We're going to push this together into a single fraction. And the lowest common denominator, some people would aim for 8, but really makes our life easier if we go 4. And on this other side, I'm going to write that as 4 on 3. So remember, 1 times 3 plus 1 gives you that as an improper fraction. The reason I'm doing that is because that's going to be the other half of our cross multiply. We need a fraction on that side to help us out. Then, what did you do to this 2 to get it to 4?
Multiplied by 2.
Good. Same with the top. and everything on the top.
2x minus 2.
Nice, yeah. Here we didn't need to do anything because it was already a 4 on the bottom. Alright, and this is where it's possible to fall into a trap. That negative applies to the entire top, both the 3x and the minus 5. So if we wanted to simplify this, we're going to have the 2x here take 3x, so negative x. And then the numbers, here's where it's particularly nasty, minus 2 minus minus 5. Yeah, minus 2 plus 5 is plus 3. It's where negatives are truly savage, but I won't give you anything more complicated than this. Equals
Then-
4 on 3.
Then you would.
Yes, then cross multiply. We've got it to this sort of golden place where we've got a fraction facing a fraction. Now we can pull off our cross multiply trick, which is that up there, this up there, which will give us 3 brackets negative x plus 3 equals 16.
Distribute.
Good, distribute. Minus 3x plus 9 equals 16. And now we're on more familiar territory. Take 9, take 9. 3, negative 3x equals 7. Divide by negative 3, divide by negative 3. X equals 7 over minus 3. Or you could write it as negative 7 on 3. Yeah. Alright, so this is towards the end of extension paper 2. Realistically, where most of you guys are up to is level 7 or 8, which is fine. And really, by the end of today, I'd like you guys to knock off level 8. Some of you guys will be ahead, but now you have note sheets, and I will give you the extension papers now. So don't stress if you're not onto these today. Ideally, end of level 8 would be a good goal for today. But you have some notes to help you jump on to the next bunch of levels. Then, do you have a computer? Awesome. Could you grab it and I'll show you how to log on to the GoFormative thing where you sort of check your answers with. It's alright? So I know what I just gave you. What is that? Cool. And I will end the video recording.